Right. Now, yesterday we have seen the directional antenna system and as well as the comparison of different antenna system like omnidirectional for different worst cases and the directional for different sectors. One is 3 sector, other one is 6 sector. After tabulating all these responses for the worst cases, we have seen all blue colors are allowed. But practically, if you see, our discussions gone in terms of considering Earth as a flat surface, and finally Earth is not flat surface, no doubt about it. Along with that, irregular terrain surfaces, there are possibility of improper traffic. For example, if an accident occurred at a place, there is a chance of densing the users at one place. Imperfect site locations, because we are in multipath environment, there is no chance of a constant signal every time all the locations. That's why we have to subtract 6 dB for the worst cases. Then whatever the signal that is satisfying the condition like C by I is greater than or equal to 18 dB, then that system can implemented practically anywhere. That's if you subtract this minus 6 dB in the obtained value of worst cases which we designed for different antenna systems. And we would like to say after this conclusion, for 3 sector, minimum K equal to 7 is the requirement. For 6 sector, we can go with K equal to 4 also. But practically, K equal to 4 will cover a limited area where more number of handoff requirements will be high. That's why to have an optimal and the best combination is K equal to 7 with 3 sector is the best combination. K equal to 3, sorry, K equal to 7 with 3 sector is the best combinations. Right. That is the first item of the minimization of interference. So 90% of your problems, 80% of your problem is minimized with the cell sectorization. Is there any additional methods that is possible, still further reducing the co-channel interference? One is lowering antenna height, creating a notch in radiation pattern, umbrella pattern, diversity receiver, tailoring the antenna beam using parasitic elements in an array. So here the concept here is, suppose if I'm doing at Tirupati, the same situation may not be available at Chittoor and Vijayawada and Hyderabad. Sometimes it may get varies. So there I cannot make multiple changes. Instead of that, what we are doing is simply we are making our simple calculations. That calculations are simple engineering interventions. That intervention will help us further reducing of co-channel interference. Let us start our discussion with the first, second one, lowering and 1 second. Hello. Right. Lowering antenna height in the valley terrain. That is, let us see, if you lower the antenna height in hilly terrain, what will happen? If you lower the antenna height in flat terrain, what will happen? If you lower the antenna height in valley terrain, what will happen? Let us start our discussions. Basically, we would like to go with only one item, actually, that is valley terrain, because it is effective, but we have to check whether it is good for hilly terrain and flat surface. So as per your book, we are discussing only hilly terrain and valley terrain, but I am including the flat terrain also, which is there as a single item at the end of your topic. Now let us see this diagram carefully. All of you see this diagram carefully. First, mobile unit, right? This is mobile unit. It is moving on a flat surface, So the path of the mobile unit is simply like a flat surface. Now, if you see, this is nothing but not a Gaussian curve. It is a hill, high hill, or a mountain. Let us take, for our discussion, we are taking hill. Height of the hill is given by capital H. Height of the hill is given by capital H. On the hill, we are going to keep the antenna, like keeping our base station on the top of the building. Likewise, keeping our base station on the hill, on the top of the hill. So first, height of the hill is given by capital H, and the height of the antenna is given by H1, and antenna is kept on the top of the hill. The effective height of the antenna is given by h plus h1. That's why you have given actual height of the antenna is given by h1. Effective height of the antenna is given by he. Here I have shown he1, but you take as he. It is up to you whether you take he or he1, no issue. Okay, right. Now effective height, actual height with respect to the mobile location, with respect to the mobile location. So if you take the mobile path location, that's why you have written here, the effective height of the antennas varies according to the location of the mobile unit. Now this is the location of the mobile unit. Now take this as a reference, this path as a reference. With respect to this reference, this is very important because based on the direction of the movement, the slope you have to take. Now it is a flat surface. Now this is the reference level I have taken. From the reference level to the antenna, whatever the height, that will be called as effective height of the antenna. Effective antenna height. Effective antenna height. That's why it's called HE, effective height of the antenna. So effective height of the height of the hill plus height of the antenna. Forgot about this color, red color, orange color, blue light. This is not required for us now for discussions. Now we have started our discussions like lowering antenna height. First, this is the actual antenna height. Effective antenna height of is given by height of the hill plus height of the antenna. Now, suppose if this antenna height is reduced by 50%, now you take the colors which I have shown here, red color, orange color. Now the 50% of the antenna height is reduced on the top of the hill. Now effective height of the antenna is what? Height of the hill plus remaining height of the antenna. So He dash, now the effective height of the antenna after reduction it is given by He dash. Earlier it is given by He. This is the actual condition. Now this is the 50% reduction condition. That's why you have written if actual height of the antenna is reduced by 50%. That means actual height of the antenna means H1 is reduced by 50%. Nothing but now from the height of the antenna, the effective height is given by He dash. He dash is equal to capital H plus 50% of the old height. So 0.5 of H1. If you reduce the antenna, then generally the gain will be affected by a factor which is given by 20 log He dash by He. The simple formula is He dash by He. 20 log He dash by He. This is the gain reduction factor for lowering antenna height or variation in the antenna height. This formula you have to keep in your mind throughout the subject. G is equal to 20 log He dash by He. He dash is nothing but after variations in the height of the antenna, it's called effective height of the antenna by actual effective height of the antenna with respect to some base. So He dash is equal to H plus 0.5 H1. Now H is nothing but H plus H1. So rearrange the equation like 20 log 1 minus half H1 by H1 plus H. Here, that's why we have taken high hill. H1 is very much less than capital H. Height of the antenna is very much less than the height of the hill. Then this factor will become 1. This factor will become 1. Sorry, this factor will become 0 because this is large. Denominator is large, then automatically this will become 0. When this becomes 0, log 1 is equal to 0 dB. Therefore, reduction in gain factor is almost negligible. If you reduce the height of the antenna on a top of hill, nothing is going to happen. This is the conclusion. Nothing is going to happen. So on the top of the hill, only condition is the height of the antenna must be very much less than the height of the hill. That is the case. This is true. So if I keep an antenna in Tirumala, now if antenna height is reduced in Tirumala, nothing is going to happen. That is not true in all the cases, only in the hill cases. Let us go with the second case. Is there any doubt? You can ask me now. I'll start with the first one and I'll ask doubts. After that, we'll move to the second one. Please. Any doubts? Any doubt regarding the first one? The antenna was kept on the Tirumala hills. If antenna height is reduced by 50%, nothing will happen in the gain factor. Suppose if I take the valley region, see the first diagram. This is the slope of the movement. This is the direction in which the mobile unit is moving. Now take the slope of this and extend the slope. Wherever it is touching, that will be the base point for effective height of the antenna. That will be the base point for effective height of the antenna. The actual height of the antenna is given by H1. This is valley region. This is valley region. The actual height of the antenna is given by H1. The effective height is given by the slope. You have to extend, 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 and you will touch here. So from here, this height is given by He1. So for our discussions, we have taken He1 is equal to 2/3 of the H1. That means 2/3 of the actual height of the antenna is effective height of the antenna, valley region. Whereas in this case, it is H plus this one. This is valley region. The slope, the mobile can able to see the antenna only up to this level. So this level we are not going to consider. Therefore, only the mobile could able to see the antenna up to this level. Therefore, this will be the base for us or reference for us. So from this point, if you calculate the height of the antenna, that will become He1, nothing but effective height of the antenna. So for our discussions, with respect to the diagram, we have taken 2 by 3 H1. How much? 2 by 3 H1. Now, if the antenna is, now take the second case. Now antenna is reduced by, that means this black color is no more valid. Now take the color, red color antenna. Now it is reduced by 50%. When you reduce by 50%, effective height is now, with respect to the reference point, this will be the effective point. Therefore, it is nothing but 2 by 3 H1 minus half H1. Because it is reduced by half. It's reduced by half. So nothing but equal to H dash is equal to this height is given by 1 by 6 of H1. 1 by 6 of H1. Students, it's very easy. Only you have to keep your mind and you have to carefully look into this. This is the path of the mobile unit. When mobile unit moves from here to here, the path seems to be, mobile could able to see only up to this level. Then this will be the reference to calculate the effective height of the antenna. So from this reference point to the top of the antenna, this will be the effective height. That is given by 2/3 of the H1. When antenna is reduced by 50%, nothing but this diagram, it is reduced by 50%. Now I am going to take only this height. Now this height is nothing but actual height minus half, 50%. So actual height is, actual means here 2 by 3, effective height. 2 by 3 H1 minus half H1 is given by 1 by 6 of H1. Because of reduction, what is the formula? Gain is equal to 20 log He dash by He. So here we have taken He1. So He1 is nothing but, He1 dash is nothing but 1 by 6 of H1 and He1 is by 2/3 of H1. So if you substitute this value here, you will get minus 12 dB. What does it mean? You have to talk, otherwise I'll stop the class today.
Gain is reduced by 12 dB.
Gain is reduced by 12 dB. That means if antenna height is reduced in a valley region, there will be a loss in the gain factor. There will be a loss in the gain factor by how much? 12 dB for 50% reduction. Suppose if this path is like this, instead of like an angle of 45 degree, if slope is 30 degree, will it be true? Will it
No,
be
sir.
true? Suppose if this slope is getting changed, direction is instead of this one 45 degree angle, if it is like 30 degree angle, what will happen? This is going to be changed. If this changes, this is going to be changed. Okay? So that's why in the first slide itself, I told very clearly the effective height of the antenna varies according to the location of the mobile unit. So this is the location of the mobile unit. Suppose if the location of the mobile unit, afterwards it is straight road. Afterwards it is straight road, for example. Now the mobile is here. Then I have to take this one as a reference. If this is the reference, this will become 1 by 8 of the H1. So automatically this is going to be weight. So always this you have to keep in your mind. This is very important parameter. The effective height of the antenna varies according to the location of the mobile unit. So here we have taken only the location of the mobile unit is here. Now extend the slope here. Now this will be the reference for both the cases. The first case, actual height and effective height. And the second case, 50% reduction, and we have taken only effective height because gain factor is given by new effective height by old effective height. If there is any variations, that's all. He dash by He simply. So always lowering antenna height is very effective in valley region, whereas there is no response. That means it is not effective in hilly terrain. Now another comedy, another funny thing. Another funny thing, in a plane surface, let us take in front of M block of Sri Vidyaniketan Engineering College, I have placed one antenna. If antenna height is reduced, what will happen? I am not going to take effective height, actual height, effective height, both are same now. The actual height of the antenna is given by H1. Now, if effective height, then I mean the effective height is also H1. Now, if antenna height is reduced by 50%, the effective height is new effective height is half H1. Now, gain is equal to half H1 by actual height. Now, how much dB you are getting?
Reduce
minus
of
6
6
dB.
dB.
Very good. Reduction of 6 dB. That means in a normal case, even at the top of the building also, because building height cannot be very much greater than the antenna height, then definitely there will be a reduction in the gain factor. That's why you cannot place the antenna as you like on the buildings. There are certain engineering calculations to find out the gain factor if height of the antenna, suppose on a top of a building, and suppose in if I am having a house at Tirupati, and if I place an antenna on the top of my building, and which is 2 floors, and another antenna on the top of an apartment which is 5 floors, will be the response gain factor same or different?
Different.
Difference.
Different. Why it is different?
Effective height change.
Effective height changes, automatically the gain factor is going to be changed. That is what I would like to say. So I have to take three items. One is on a high hill, other one is in a valley region, third one in a plain surface. In all the surfaces, one common point is taken to calculate by lowering antenna height is only 50% in all the cases we have checked. Suppose if it's reduced by 40%, what will happen? If it's reduced by 20%, what will happen? If it's reduced by 60%, what will happen? In your examination, if I ask reduce the antenna height by 75% and see the and calculate the gain factor, what you will do in hilly terrain, valley terrain, and a plain terrain, for example. Now, what you will do?
0.25 H1.
Very good. You have to take this one as what? Only 0 point.
0.25.
Very
25.
good. 60% means?
0.6.
0.4.
Very good. Very good. Very good. Very good. That's all. Suppose if this angle has been changed, I didn't given it is two-third. Now instead of 45 degrees, see this angle seems to be like 45 degree slope. Suppose if I take 30-degree slope, will you take this same thing? Or if
Yes,
I
sir.
take a straight line here, from here I take a straight line. Now how you will be calculating this value?
One
Will it,
third.
one third or two-third or a half? Okay. Take scale and calculate. Take scale and calculate. Take a straight line here and just suppose instead of slope, if I take straight line here from here onwards, now mobility is in the straight line. Now I have to extend the line up to here. So it will be 50% of the antenna. Okay. These are all with respect to the scenario, it will change because we have written where is accordance with the location of the mobile unit. So this is the scenario I have taken for discussion. Tomorrow, instead of this slope, suppose if slope is like this, what will happen? Slope is like this, what will happen? Then the slope, the mobility is here, then automatically it will become He1 and H1 are same. So that is what you have to keep in your mind. So in plane surface also, if antenna height reduces, the gain is going to be lost. Suppose if you say, sir, I am not getting good signal, then what people will do? They will raise the antenna in a plane surfaces generally. That is what we have discussed. Is there any doubt? You can ask me now. Still,
Sir, what about the mobile unities in the hilly areas? On hill.
on hilly area, what will happen? So this is the question you are asking. Suppose if mobile unit is here, okay, that's what you are asking.
Yes.
Mobile, take the slope. Now this is the slope, okay? This is the slope. Now this will become effective area.
Yes, sir.
Suppose if mobile unit is here, then what you will be doing? You will be extending the slope, so it will be the reference level. From here, you have to calculate. This is nothing but you have kept the antenna on the top of the hill, and mobile unit is in a plane surface. This is one scenario I have taken. That's all. In the examination, I can give one diagram, and you can estimate the value also. That will come in the next unit also. Don't worry. Okay.
Okay.
See the mobile unit location and extend the path. That's all. You calculate. You take it as a reference. See H1, this will be the reference. Suppose some hill is there, small hill, and your mobile is here. Now take the slope of that and find out the He1. That's it. Still any doubt? Still any doubt?
No,
Students,
sir.
shall I move to next topic?
Yes, sir.
Right. Okay. This is quite interesting. Creating notch in the radiation pattern. What do you mean by notch? What do you mean by notch?
Opening, small opening.
Suppose in your car there is some dent. There is some dent. It is also sometimes you will be calling it as notch. Let us take vessel. If you put on floor, what will happen? In Telugu, they will be called as nokku poyindantaru kadamma. Same thing. Notch maybe dent, need not to be like open. Here in this case, we are talking about the dent, dent in the radiation patterns. We are creating a dent in the radiation pattern. Okay. If you see this diagram, you will understand. You see this diagram. Now the blue color line which I have drawn, this is the actual radiation pattern of an antenna, directional antenna. Is it true or not? The blue color line or the diagram which I have drawn, blue color round, this is the radiation pattern of the antenna. Now, why the radiation pattern has been bent here? Nothing but creating a notch in the radiation pattern. Let us see how can you create a notch. Let us see how can you create a notch. Why it is also required to create a notch in the radiation pattern. That is what. Our intention is, suppose if I am taking one sector, this is one base cell, this is co-channel cell, nothing but interfering cell. This is service cell. Now maximum cell is how much degree for the base cell radiation pattern? How much degree?
19
19
degree.
degree.
Yes. Suppose your base servicing cell radiation pattern having 19 degrees, this 19 degrees angle, then it is going to cover the entire area of the cell, interfering cell. Okay. First part. Now I have to create, this is the radiation pattern, for example, this is the radiation pattern. I have to create the notch in the radiation pattern. This radiation pattern, see, this is the service cell, this is the co-channel cell. Now I am keeping my antenna to cover this area. My antenna not only covering this area, but also covering the co-channel cells also.
Coach.
Not only covering my area, but also creating some problem to the co-channel cells. Because my radiation pattern is like this. I cannot make any changes in that. So what I have to do? If I reduce this power, then the coverage area may get damaged sometimes within the sector. So what I will do is, instead of making a radiation pattern like this, we make a dent in the radiation pattern. Is it possible to create a dent in the radiation pattern? Yes, it is possible. How it is possible? Rotate clockwise by 10 degree. Servicing cell, this antenna, you rotate the antenna in clockwise direction by 10 degree. Rotating. Then tilt the antenna between 18 to 24 degrees. Then you will get what? The dent in the radiation pattern. The notch will be created only by following these two conditions in the service cell antennas. You have to rotate the antenna by 10 degree. That means antenna like this, you have to rotate by 10 degree and you have to tilt the beam by 18 degree. After rotation, if you apply tilt, then there is a chance of getting the dent like this. One thing, this is 10 degree fixed, but here 18 to 24. 18, dent will be less. You can see the diagram, dent will be less. In 20, dent is more. 22 more. 24, excellent. 24, excellent. Tilting of antenna can be done in two ways. One is electronic tilting, other one is mechanical tilting. Here, in the communication model, cellular and mobile communication model, we are doing electronically. Rotate clockwise direction by mechanically and tilting by electronically. How can you tilt an antenna? Changing the phases among the elements of collinear array. That's all. In an array, you change the phases, then automatically the beam is, the antenna is going to be tilt. Beam is going to be tilt. So rotation with tilt. I'll ask one question. All of you. Now I'll stop sharing. I'll ask you to switch on the video. Please switch on the video, all of you, for a while, just for a while. All of you, please switch on the video. All of you, please switch on the video. Very good, very good, very good, very good. Right, right, enough, right, enough, right. Now you are looking to your monitor in a straight fashion, okay? Bend your head, and see your monitor, please. All of you do it. Not like this. You bend at least 50%, at least 45-degree bend. 45 degrees bend. Could you able to find any difficult? I mean, it is very difficult to see, okay? And it is very difficult. See, now look at straight, see the names and roll numbers of your friends. Now bend it and see the roll numbers and name of your friend. Which one is comfortable for you?
Straight C.
Why? Why straight? Why there is a problem in bending? Your eyes is also getting bended. Why? Where is the problem with you?
Line of sights.
That is nothing but the radiation pattern of the eye is getting changed. If I rotate and if I bend like this, and now you rotate it, now you bend up and down. See the difference, small difference you will be finding. The same thing is happening in your antenna also. If I bend my head like this, then problem is what? Our eyes could not be able to read in a fast manner. Okay, if I rotate like this, even my clarity and the size of angle which I am covering is also going to change. Likewise, now you can switch off your videos, don't worry. Likewise, if I rotate clockwise by 10 degree and tilting the antenna by between 18 to 24, that means less than 18 you cannot find any dent in this. Less than 18 you cannot find any dent in this. After 18 degree of tilting, then slowly the dent will start. This is the dent. Now if you increase the angle, the dent will increase. After 24, now you cannot estimate how will be the radiation pattern. So that's why maximum the tilting can be from 18 degrees to 24 degrees. Now you can ask me any doubt regarding creating a notch in the radiation pattern. Nothing but this is the simple radiation pattern which you have. Now this radiation pattern, you are making the dent in the radiation pattern. So instead of smooth, you are making your radiation pattern like this. Now that dent will not cover the co-channel cell. Therefore, the signal carrier power which is creating as interference here is avoided because of creating a notch in the radiation pattern. This is one method. Whether people are using or not, that is immaterial. These are the different techniques that can be applied to an antenna system to reduce the interference in the co-channel cells. That is what we have written here. One is cell sectorization. If cell is sectored, the number of co-channel cells is going to be reduced. So interference is reduced. Lowering antenna height in valley region or in a plane surface, if antenna height is reduced, now the signal which is radiated, that is creating a problem to the co-channel cell is going to be reduced. Creating a notch. Here also, if it is reduced, gain factor is reduced by 50%, the signal of this antenna creating to the co-channel is going to be reduced. The signal of this antenna creating to the co-channel is going to be reduced. The signal of this antenna creating to the co-channel is going to be reduced. All these are nothing but you are doing something in your servicing cell. When you do something in your servicing cell, that is going to create a reduction of signal power here, which we call it as interference. Here the actual signal here we will call as carrier signal. Here we will call it as interference signal. The signal which is radiated by this base station is creating an interference here. It will be called as carrier power here. It will be called as interference power here. That's it. Any doubt you can ask me. If you have any doubt, you can ask me now.
Sir, is there any reduce in coverage areas by this?
No. See, that's why I have shown. Now see, is there any problem here?
No, sir.
Is there any problem here?
No, sir.
No. Is there any problem here? Yes.
No, yes, sir.
Here. Right side.
Interference will be reduced.
Yes, interference will be reduced, but no changes here. Is it okay?
Yes, sir.
Next. Here also, if you reduce the here gain factor will be reduced by how much? Minus 6 dB. That gain factor will be covered with the diversity. If this gain factor reduces, automatically the co-channel cell gain factor is also going to be reduced. Now, whatever the loss I am getting here is going to be compensated in other method. That is nothing but using diversity. Okay, that will be discussing in the afternoon class. Don't worry. Today afternoon, I think we have class.
Yes,
At
sir.
what time we have class today afternoon? CMC again? 3. Okay. Now tell me from the beginning. Just I'll show the idea. This slide will teach you more. Omnidirectional. I6 number of I's are there. 6 contributors are there. If I go with 3 sectors, 2 contributors will be there. If I go with the 6 sector, only 1 contributor is there. So all denominator is getting reduced because of sectorization. So 80% of your problem is solved, but 20% problem will be reduced by using the method either lowering antenna height, or creating a notch in the radiation pattern, or maybe umbrella pattern, or maybe diversity receiver, or maybe tailoring antenna beam using passive units. Right. My question to all of you is today I'll take this diagram for discussion. One second, where is my diagram? I think some diagram is missing. Okay. I'll show another diagram. Just wait. Yes. 1 second. Could you able to see this PDF? All of you?
Yes,
Yes,
sir.
sir.
Right, very good. One diagram I would like to show to you. I didn't get that. One diagram. Wait, I'll show. They're all there in your textbook, right? Now see this. The service antenna. This is what? 1. K equal to 1. K equal to 7 parallel 1 channel. Again 1 where it is? Here. The entire cell is covered with how much degree? How much
19
degree?
degrees.
19 degree of the servicing cell radiation pattern. Okay, that is what the first thing. The second thing is, if I reduce some power here, that should not affect this area, but it has to affect this. That can be done with the directional only one case. But whereas in the lowering antenna height, if I reduce the antenna, gain factor reduces here also both. But here that will be compensated using diversity. Is compensated using diversity. Okay, that's what we are going to see in the next class. The another item which I would like to share to you is, see, this is what there in your textbook also. But plane surface diagrams are not there in your textbook, but I have taken for discussion based on this equation. Okay, creating a notch, I'll show the diagram what is there in the textbook. So when you go there, no need to discuss all these things. That is not required for us. This is nothing but simply tilting the beam. Now what we did is rotating and tilting put together, you'll get the notch. Okay. Right. One thing I forgot to talk to you is, right. Suppose, let us take your mobile phone. I'll stop the sharing. I'll show my with my hands. I'll show. Take your mobile phone. Keep your hands like this. See the signal strength how it is. Inside you can see signal strength, phone status, like it is. Close your phone. See the signal strength. Close only some portion. Open your phone and see the signal strength. Keep the same phone under the bench and see what is the signal strength. Will be same or different?
Different.
Why it is
Difference.
different? Why it is different?
Obstacles are
Very good. The paths are obstructed by my hand. Suppose if the same thing is obstructed by a glass, the same thing is obstructed by a metal, will be the reduction same?
Difference.
Why? Because is each penetration,
Material.
no, the penetration with respect to the materials which was closer to the phone is going to be, or obstructed path is going to be. Sometimes, if wall size is very width, the wall width is very large, the penetration will be poor. Sometimes in the car, if you use bulletproof glasses in the car, which has metal and also film, simple film, to avoid sunlight, people are using black film, green films. That film is also more absorbs more power. The reason is it contains metallic particles. When signal moves, when signal radiates into the car, this glass along with metal sheets, nothing but films, will absorb most of the power and only you will get less powers. That's why in the same place also, from car to car, the signal strength varies sometimes. Suppose in your home, you are using two different phones, three different phones. All are BSNL, for example. Sometimes someone will get signal and the others may not get signal. Why? What is the reason? All are BSNL only. All are Geo. All are some service provider. Tell me why. At least you understand the question. At least you understand the question. Students, my question is, let us take one service provider, three different users in the same room, in the same place. Sometimes someone will get signals and someone is not getting signals. Why? What is the reason? Some of you are getting signals, some of them will get signals, some of them are not getting signal. Why? What is the reason? Same service providers, all are in the same position. Why? What is the reason? If you keep quiet, I cannot answer. You do the experiment
Depends on
because
position on.
all three phones are kept on the same place on a table.
The mobile
Will be the signal
capability.
strength same? Will be the signal strength same? Sometimes same, sometimes may not be. Why? Very good. Somebody
Device
told 23.
capability.
23 told something. Very good. What more? 23.
Device capabilities.
Ah, why? Very good. Because device capability. Suppose if I'm using this phone is having some cover. See, this is the cover. You are purchasing many covers. Someone has metallic, these covers are made up of different materials. Suppose you remove the cover and keep the phones of same company, same model. Again, will be the signal same sometimes? Is there any guarantee? Have you checked at least? I think all of you are in right now in your home. Okay, please check Cell Light Info Display. Download an app called Cell Light Info Display and just check the signal power how much you are getting. Take the mobile into your entire house and see the signal strength, but don't move at a fast pace. Go to some other place in bedroom, four corners, spend at least 5 seconds or 6 seconds in every corner and move like that. You move to every room and just check out the signal strength in your home so that you can say what is the signal strength of a particular service provider in your home. Take another service provider and see. Or if if two mobiles having the same service provider in your home, let us take Geo for example. Take two phones, download this app, and just the signal power of the two phones and calculate so that you will understand what is the problem. Whether problem is with the equipment, or problem is with you, or problem is with the antennas, or problem is with the room, or problem is with what. Then only you can experience like an engineer. Otherwise, eating, listening to class, sleeping, you never become an engineer. Just do this small experiment. All of you are at home now. Almost all the members in the home are having at least one phone, and that is smartphones. Download Cellular info displays. Cellular info is something app. See the signal power of same service provider, different service provider, so that you will understand what really actually is happening in the cellular mobile communications. Will you do it today or tomorrow?
Today.
Today, right? Do it and tell me. You do the first experiment. It is very difficult. You will get confused. Someone will do one thing, other one. Instead of avoiding confusion, do one thing. You take the same service provider, two mobiles, download that app, and check at every corner of the home by keeping two phones near to each other. Near to each other. Keep it on a table. Move the table to next stage, next stage, next stage, next stage. That's all. Not on the metal table. Keep it on a wood table or in a plastic chair. Do it, and please let me know at least by the end of this week. All of you, do the small experiment, or do the small experiment, keeping like hand like this, closing your mobile like this, close with keep it in glassware, keep it in a vessel. Take one glass without water, put your mobile phone into the glass and see the signal power. You could be able to see this, and you can experience what is the actual problem that is happening in the mobile communications. Okay, that's all. Any doubts? Still, you can ask me. Any doubts? No doubts. Thank you all. Shall I wind up? Again, we'll meet at 3 o'clock. Thank you all.